Good morning, ladies and gentlemen. My name is Tawanda. I'm a student here at Automation Works Training Facility, and today I'll be presenting you with my design project for the first term where we discovered Python-based programming. But before I go on with my project, I just want to showcase you what I did for the 3 previous terms. So in the first term, we learned about 3D designs, and um, we focused more on mechanical engineering. I designed a toilet paper holder that can keep the toilet paper in public restrooms more safely secured. And in the second term, where we explored Arduino programming, I designed a device I called the timekeeper to help with time management. And in the third term, where we focused on industrial automation, I designed a machine that can compress semi-dry cow dung into equal-sized blocks to be used as raw material for applications such as building or making all sort of products by using the cow dung as raw material. And now to get to this term's present design project. My motivation for this project came from when I noticed that in my community, Bafiaksrafir, there is no automated system in place to let the community members know when the bridge we have here has been flooded. And if you're a resident here, you know the pain of driving to the bridge and then having to turn back because you didn't know it was closed. So then I decided to build a Python-based alert app to alert communities when bridges have overflown. Not only focusing on my community, but also communities that have the same problem. And this app will therefore save them the time and effort to check the river conditions themselves. In my solution process, I first looked at the requirements I would need for my project, and I had to incorporate networking, graphical user interface, and use a device such as a microcontroller or a sensor. Then I had to look at how everything would interact with one another, how the app would communicate with the microcontroller, and then I had to consider the simplicity of my project to make it user-friendly, lightweight, and cost-effective. In the real world, this app would be useful for motorists, pedestrians, or even tourists or emergency personnel to alert them when the bridge is flooded, so that they know they have to take an alternative route or avoid the route. And in other fields, the historical data I keep on the app can also be used for planning, research and stats, and urban planning. This is just a little diagram that shows how my app works. So when you open the app, it opens up as a home page, and then at the home page you have the option to see the alert page or the level page, which will be part of my future improvements. So when you open the alert page, you can see the alert, and then you also have the option to open the history, and then when you're done viewing the history, you can go back to the alert. So how the app receives its alert is through an MQTT broker. So the microcontroller I use, which I will expand on in the next slide, connects to the internet with a topic, or it connects to the MQTT broker with the topic Tawanda alert. Then my app subscribes to the MQTT broker with the same topic so that it can get alerts only from my topic from the MQTT broker. The broker is basically a middleman for the app and the microcontroller so that they can communicate with one another, because the app can't directly communicate with the microcontroller. It needs that middleman. And these are all the physical hardware I used. In my project, I used a microcontroller that runs my code. It's a A9 GSM model, which can hold a SIM card and also a SD card. The SIM card has data on it so that the microcontroller can connect to the internet and therefore connect to the MQTT broker. What's innovative about my project is that my app is a multi-platform mobile app, which means it doesn't only run on PCs, but it can also run on phones, tablets, yeah, and all other smart devices. And it also gives you remote real-time updates. So you can be in America. When you open the app, you will see whether the bridge is flooded or not. And I also use a Telegram group to which the app sends my alerts to, through which members of the community can also be added on the group and they can discuss other current alerts that are going on in the community. So when I started my design process, first started with my hand sketches just to get an idea of what I want my app to look like. So this is the idea I had for my homepage, my level page, and my alert page. And later on, when I started coding, it turned into this. So this is my homepage. As you can see, you have two options at the homepage. You can either view the alert or you can view the dam level, which will be part of my future improvements. And this is what the alert page looks like, and the level page. So the alternatives I had was either to upload Arduino onto the microcontroller or upload MicroPython onto the microcontroller. And I went with MicroPython because it allows for easier integration with the MicroPython app. Rather than Arduino, which would be much more complex for me to integrate with. And MicroPython also allows for easier and quicker testing, and it has a more better extensive library support. A library is basically a tool we use to complete our codes. I can explain it as this in simple terms. Let's say you want to bake a cake, and you need your ingredients such as sugar, flour, baking soda. Now, instead of you physically making the sugar and flour, you go to the store and buy the sugar and flour. That's basically what libraries are. They are tools that we can use to bake our cake or to make our code work. And with MicroPython, I also have direct access to the files I've uploaded onto the microcontroller. Then with Arduino, I do not have access to the file system. And to physically detect whether there's a flood or not, I considered using an ultrasonic sensor, an ultrasonic distance sensor, which uses sound waves that come from the sensor, bounce off or reflect off a surface, and then comes back to the sensor, and then the sensor detects how long it took for those sound waves to return to the sensor, therefore calculating the distance. Or I had the option of choosing a float switch that is always in two states. It's either activated or it's not. So you know it's either flooded or it's not. And I went with using a float switch because it doesn't need any calibration. Like the distance sensor is cheaper and it provides more consistent results than the ultrasonic distance sensor, because let's say I'm trying to detect the height of the water and therefore tell if there's a flood or not, and then there's a log in the water or in the river, then the sound waves bounce off the log instead of the surface of the water, then my app would say there's a flood while there isn't a flood. So yeah, in that way, the float switch would have been much more simpler, and it also consumes less power than the distance sensor. And when I started testing my code, so this is the code that's running on the microcontroller. So this is the MicroPython code. So while it's running in the background, these are the debug messages that come in the terminal that just shows how the code is running in the background. So as you can see there, it first checks if there's a SIM card present, then it checks if the SIM card is data so that it can connect to the internet. Then it connects to my MQTT broker, that middleman I talked about, and then it sends the message to the broker. And then in my app, this is the code in my app, the app then connects to the topic on the MQTT broker so that it can receive those messages that are being sent by the microcontroller itself. So these are the messages that are received. So it's either there's a flood or there isn't a flood, because the float switch is always in two states. It's either activated or it's not. And this is where I started testing my Telegram to see if my Telegram group can receive the alerts or not. So this is my this is my terminal in the app that just shows whether the message has been sent successfully to Telegram or not. As you can see there, these were the successful tests. Here were the messages that I received. So it only sends an alert to the app when there's a change. It's either there's a flood or the flood is gone away, or it's either there's no flood and then there's a flood and now the flood is gone away. And the software tools I used were my PyCharm IDE, which is the environment I used to code my app in. And these are the library tools I used. And for my MicroPython code, which means the code that's running on the board itself, on the microcontroller, I used Thorny IDE or environment, and I used these libraries or tools to make my code run smoothly. The skills I obtained throughout this project was I learned how to do Python-based programming, to schedule and plan my project better. And I also gained a deeper technical understanding of how the microcontrollers work and communicate with apps. And I improved my adaptability when faced with challenges throughout the design project. The skills I demonstrated were my research skills, problem solving, and also to focus on simplicity rather than trying to complete a complex design project, which would have been difficult to complete, seeing that I'm a beginner developer. So my assembly sequence went as follows. I first started planning my project, the hand sketches, how my graphical user interface would look like. Then I started testing individual features, such as can my app so to replace the function of the float switch, I used a button instead, because a button is also either activated, or it's either pressed or it's not. And the float switch is either activated or it's not. So I just replaced, instead of buying a physical float switch, I just used a button. So I tested whether my button can send the alerts to the app. And then I had to integrate the features, like integrating my MicroPython code with my app code to see if they can integrate with one another. And then my final step was refining and testing the app as a whole. For my research, you remember the middleman I talked about that lets the app communicate with my microcontroller? I had the following options of that middleman, which were using an MQTT broker, HTTPS, or a WebSocket or long-range communication, which using an MQTT broker was the easiest one to implement in my project. And to program my app, I had an option of using the following tools, which were Kiwi or Tawanda. These tools are mainly used to create the graphical user interface. So if I had used Tawanda, it would have been more difficult to run my app on a smartphone because Tawanda lacks mobile support, while Kiwi can run on all devices. And for my community group, I had an option of creating the group in WhatsApp or in Telegram by using either one's API. An API is basically permission to use their platform for your app. So with WhatsApp, it was the more expensive option to go with because WhatsApp comes with a monthly charge while Telegram's API was free. And this is just the link I used to get a better understanding of how to integrate Telegram with Python. And this is how I finally applied all my research. So I went with Kiwi as the tool to code my graphical user interface because it supports touch devices such as smartphones, and it shows data clearly, it's free and reliable. And for that middleman, I chose to go with MQTT, because it has easier communication, it works fast, consumes lower power, and is reliable and simple to set up, especially for a beginner like me. And for my group, I chose to go with Telegram. As I said, it's free and it also has no limits to the amount of messages I can send to the group, while WhatsApp comes with a monthly charge, and they also have limits to the amount of messages you can send to the group. And this is my activity log, which shows how I spent my time throughout this term. As you can see there, the biggest chunk went to the design project and my theory. Then it was my PPD, which I will expand on in the next slide, and my tutorial project where we learned how to code a Pong game. So for my most impactful PPD topics, PPD is our personal professional development, which we were offered by JC. So the most impactful topics I learned this term were Ashby's law of requisitive variety. It entails a lot of things, but what I learned from it was that to always have more solutions to one problem, because if one problem doesn't work out, you have more solutions from which you can expand on or try to solve your problem with. And being a good listener, because being a good listener makes you a more attractive person, especially to the person you're listening to. And to anticipate threats. I had to anticipate a lot of threats in my design project, think of the setbacks I can face, and try to compensate some time in my design project. So I always try to stay ahead so that if I face a setback, I always have time to recover. And the technical difficulties I faced were installing and running MicroPython, because it is quite a long process, and also to import the libraries, or as I said before, the tools that make the app run. And the hardware difficulties I faced were with my setup here. The wires were too fragile at times, so sometimes I would knock one wire out of place and start receiving errors, which I didn't understand until I noticed, hey, the wire is out. And there's also a reset button on the microcontroller that sometimes didn't work. So to try and keep my tests consistent, I took note of the first 8 tests I did for my project. So to try and connect to the MQTT broker, I failed on the first couple of tries because it was my first time. But after then, I started getting more success. So out of the first 8 tests, I had a 75% success rate. And also to receive the alerts from the microcontroller to the board or to the app, I sometimes struggled, but this was mainly due to the wire not being in place. But I had an overall 85% success rate. And to test if my Telegram can receive the alerts or not, at first, I didn't realize that after making the so I had to first make a bot on Telegram, and this bot receives then the signal from my app and then sends it to a group. So I thought the bot would be the group itself instead of I having to make a group. So I tried to add members onto the bot instead of adding members to a group. So yeah, I first had some difficulty with that in the beginning. And then to test my button, I had 100% accuracy because yeah, it was quite a simple thing to do. So my button is essentially my float switch. The tools, the lessons I learned in the project were to use tools that can integrate with each other much easier, like using MicroPython with Python instead of using Python with Arduino, which is a whole separate language. And to always make sure you understand external source code. Like, I'm far from being a perfect developer, so I had to do a lot of research and get codes on YouTube videos or websites. So when I got errors in the beginning and I didn't know how to fix those errors, I had to go back to the video and make sure I understand the code fully before I try to modify it. And lastly, to structure your code neatly so that when you want to make a change in your code, you know where everything is, you know where each function is in the app. For my future improvements, as I mentioned before, I want to, or actually I didn't mention before, I want to incorporate stats reports into my app so that it can take stats on the river. And not only on the river, I also want to monitor the dam's conditions, and I want to improve the overall app layout because I feel my app is still too basic. And this is my bill of materials. Luckily, I was able to find all the hardware I used here at Automation Works Training Facility. And I spent in total 134 hours on the whole project. And it cost me 304 Rand. I'd just like to give my acknowledgements to the following people. Mr. Vainan Kotze for giving me the opportunity to be able to complete this course. It is something that I could have never predicted if you would have asked me a year ago. And also to JC for not only the impactful PPD, but also the life lessons in between and after the PPD sessions. For Nicholas Collins for teaching me the technical knowledge I know, and for teaching me how to help myself if I encounter technical difficulties. And Daniel Yalmari for always being a support pillar and motivation throughout the year. And my classmates, which were my first go-to before I went to Nick when I struggled with technical difficulties. And now for my demonstration.